Here we are looking at a very involved problem that requires many steps, simple steps, but they need to be followed appropriately if you want to get the answer in determining the shortest distance from a point to a line. So we're given a point C over here in our diagram with coordinates equal to 3, 1. So I'm going to write that in over here. My point C has coordinates 3, 1. And we're given 2 points that define a line somewhere else. This point B is given by 10, 7, and the point A is given by 2, 9. So I'm going to write that in, 2, 9. So examine the point C and the line segment AB, and if I drew a line from point C to the line segment AB, at what angle would they meet in such a way that I can make the shortest line possible? So let's just look at a common understanding of this picture here, simple understanding. I have my point C, I draw a line to AB. So that's where they intersect, right here. Now, can I draw a shorter line? Yes, I can. If I go a little bit less steep, I think this line is going to be shorter than the previous one. Same thing, I can go from the other side. I can go out here. If I draw a line that's a little bit, sorry, not less steep, but more steep, I get a shorter line. I mean, to really illustrate that, if I were to draw a line from here all the way out to somewhere out here, you can see that line is definitely longer than this one and this one. Okay, but what is the shortest possible line? Well, as it turns out, the shortest line connecting point C to the line AB happens to be the line that is exactly perpendicular to AB. Okay, so that's this line that intersects at a right angle. So what we're going to do to start off, I mean, the end goal is actually to determine the length of this line. We want to find the length of this shortest line. Let me get a red here. From C to the point of intersection of that line. That's essentially what we want to aim for at the very end, to get that distance. But we're going to take a few steps back and first calculate what that line is, that line that intersects AB, and figure out an equation for it. Okay, so that brings us to step number 2. We want to find the equation of the shortest line connecting point C to the line segment AB. So the equation of the line, it's going to be, first of all, a straight line. So I can write y equals mx plus b. And what I need here is a value for the slope m and a value for the y-intercept b. Now, do I have any of this information from my graph? No, but I can determine some of it analytically using the points A and B. And what I'm referring to specifically is this right angle here. Now, if you recall, any two lines that are perpendicular to each other have slopes that are negative reciprocals. So let me calculate the slope of AB. Okay, I'll do that over to the side here. I have slope of AB, so MAB is equal to y2 minus y1, so it's going to be 5 minus 9 over x2 minus x1, which is 10 minus 2. That leaves me with negative 4 over 8, which if I simplify becomes negative 1 over 2. So that's the slope of AB, which means that the slope of the slope of the line passing through C is going to be the negative reciprocal. So here I have a slope of 1 over 2. That means the slope of this line here is going to be 2 over 1, or just 2. And I'll simplify my little diagram here and just write 2. So the slope of this line is 2. I can go to this equation here and erase the m and write in a 2 over here. And now I have to figure out my b value, which is my y-intercept, but I can do that because I have a point that passes through this line. Okay, that point is 3, 1. So what I'm going to do is substitute those points, those coordinates, into my expression over here for x and y, and that way I can determine what my b value is. So for my y value, I'm going to put in a 1. For my x value, I'm going to put in a 3. Then I have a plus b do some math here, I get 6 plus b. And if I rearrange, I end up with b is equal to 1 minus 6, which is equal to negative 5. So the equation of this line is y equals 2x minus 5. And that's the equation of my perpendicular line to AB. Now, we're not done yet because I want to find the shortest distance from the point C to the line AB. And that requires, if I want to find a distance, if you remember from a previous lesson, to find the distance I need 2 points. And currently, I only have one. If I look at my diagram here, all I'm given is the point C, which is on that line. I need to figure out what that point of intersection over here is. Okay, so let's call this point D. Now to find a point of intersection, I need the equation of 2 lines. And currently, I only have the equation of 1 line. That is this line here. And I'm going to erase this slope value. The equation of this line is y equals 2x minus 5. I need the equation of this line here for AB. So I already know the slope of that line. I calculated it previously. It's negative 1 over 2. So let me go on here and maybe write the equation of line AB with as much information as I have, and that really is just the slope. So it's negative 1 over 2. To solve for my b value, I'm going to sub in the value of a and solve for b. So sub in a, which is the point 2, 9, and solve for b. So in order to do that, I'm going to replace the y with 9. That equals negative 1 over 2 times 2 plus b. That gives me 9 equals negative 1 because the 2's cancel, plus b, which means that b is equal to 10. Okay, and my equation of the line AB is going to be, well, I can pretty much just take this, paste it here, erase my b value, and replace it with a positive 10. So it'll be plus 10, period. So we're on the right path here. I have now 2 equations. I have the equation of my line AB, which I'll write now on my little picture here, my little diagram. So the equation of this line is y equals negative 1 over 2x, and that's going to be plus 10. And to find the point of intersection, I can use method of elimination or substitution. So let's put the 2 equations together. Let me copy this guy here, paste him here. Here are my 2 equations. I'm going to copy both of them, put them over here. I want to find the point of intersection of these 2 guys. Well, if you notice, they're both equal to y. And if they are both equal to y, then the equations, and that's a little equal sign, are both equal to each other. What do I mean by that? Well, this equation here, I'll get a little bit more, this equation here is equal to this. And I don't need any y over here. Okay, I can just use this equation involving x, and once I've solved for x, I've solved for y. So let's begin. I'm going to use substitution here and rearrange, isolate my x variable. So on my left-hand side, I'll bring my x values. So negative 1 over 2x minus 2x is equal to negative 5. And that'll become minus 10. And this now becomes negative 2.5. So I'm going to change this fraction to a decimal. Again, I know usually I do not encourage converting fractions into decimals, but in this case, 1 over 2 is a terminating decimal, so it's exactly that number. Then I have minus 15 over here, divide both sides by negative 2.5, negative 2.5, cancel, cancel, and I get x is equal to, let's take a look here, 15 divided by 2.5 gives me 6. If I want to solve for the y value now. I'm going to take this equation for y, so y equals 2x minus 5. I'm going to replace that x with a value of 6, so 2 times 6 minus 5, and that gives me 12 minus 5, which is 7. Okay, so finally, all this work to determine that the y-coordinate is 7, the x-coordinate is 6, the point of intersection, which is the same as the value of d, is equal to 6 comma 7. So 6 comma 7. Let's put that on our diagram just so we know what's going on here. So 6 comma 7 is this guy right here, my d value. So d is 6 comma 7. And again, my diagram is a bit off. This should have been over here, the point, but that's okay. So I got 2 points. I have my point C, I have my point D. The final step is to find the distance of the line segment, the shortest distance from point C to AB. And that requires that I use the distance formula. So again, if you recall, the distance formula looks like the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to put in the points C and D. So let me just maybe collect them together so I have them in front of me. So here's my D value, which I'll put over here. And then I have my C value, which is this guy. And I will copy the C value here and place it over here. Clean it up a bit. So here's my C value. And I can put my points in. So let's take a look. I'm going to copy this whole formula because I pretty much need everything except I'm going to change the variables. So I'm going to take out x2, x1, y2, y1. I'm going to replace it with 1 minus 7. And actually those were the y's first. So let me put the x's first. 3 minus 6 and 1 minus 7. This leaves me with 3 minus 6 is negative 3 squared plus negative 6 squared. Square root gives me 9 plus 36, which is the square root of 45. And finally, on your calculator, make sure you know how to take the square root of a number. You're left with, and I'm going to make approximate calculation, 6.71. There you have it. So all this work, and I can't even fit it on one screen, but all this work to determine the length of this line here. Okay, so it is involved. I would recommend that you try some of these on your own. Maybe rewatch this video so that you understand each step and why you do it, why it is necessary to do these steps to find this shortest distance.